Okay, welcome everyone. Dr. Lindner here. In this lecture, we're going to be talking about muscles. And when we talk about muscles, I think you'll think back to an earlier lecture where we talked about tissues. And when we covered the topic of muscles, we said there were three types of muscles. We said there's skeletal muscle, smooth muscle, and cardiac muscle. And of the three muscles, we said that skeletal muscle was the only one that you had voluntary conscious control over. And in today's lecture, we're going to be talking about skeletal muscle, focusing on that. So, what are some of the functions of muscle tissue? Let's put on blue here. So, one of them is producing body movements. Now, we know that when muscles contract, they create tension, and tension from the muscle is transmitted to the tendons, and tendons attach to bones. So muscles attach to bones by way of tendons. Muscles provide the contractile force that's transmitted to the tendons. The tendons are somewhat inelastic, and you get this pulling sensation on bones to create movement. Now, the term contraction, when I say muscles contract, the term contraction is implying that there's tension that's being generated. Most people jump to conclusions and say, all right, when it's contracting, it must be shortening. But we know that muscles can contract in a variety of ways, right? Muscles can shorten, they can lengthen, and they can remain the same length, right? But in all three of them, there's tension that's being generated. So that's the key word that I want you to focus on. Tension being generated within the muscle. Muscles have the ability of stabilizing body positions. And that's because, as I said, when muscles contract, they can shorten, lengthen, or remain the same length. If you think about postural muscles, when you're standing, it's important that all your spinal muscles contract to create tension, to create healthy posture. Muscles are involved in storing and mobilizing substances within the body. Well, what is stored within muscle? We have something called glucose. And we know that glucose, anything that ends in ose, like glucose, fructose, sucrose, they're sugars. And glucose in high concentrations is toxic. It's toxic to the brain, it's toxic to the neurons, it's toxic to your eyes, to your blood vessels. So your body will take glucose. If there's too much of it, then it will put it in storage. And the storage form of glucose is something called glycogen. And anything that ends in ogen is inactive. So glycogen is the stored form of glucose, and it's found and stored in two places. It's stored in the liver, that's place number one, and place number two, it's going to be stored in muscles. Okay, so as your body needs it, if it needs to tap into glucose stores, let's say a person is fasting and they're not eating, then your body will take it from the muscles. And then when there's nothing left in the muscles, it goes for the liver. And when there's nothing left in the liver, you're tapped out. And when you're tapped out, they call that hitting the wall. Like when marathon runners hit the wall, they just collapse, right? The nervous system, the brain has no more glucose for fuel, for energy. Okay, so yes, muscles will store glucose in the form of glycogen, and it mobilizes substances throughout the body because when muscles contract, it creates a pumping mechanism. And we know that when muscles contract, they do generate heat. That's why when you exercise, your body gets warm and you perspire to cool off your body. We know when someone has a fever, all of a sudden their bodies, they get the shivers or the chills, and as their body is shaking, those muscles are contracting, it generates heat. We know when you're cold and you're outside and the weather is 37 degrees and it's cold, right? Your jaw shivers, you generate heat. Muscles are electrically excitable. We will be learning about something called the neuromuscular junction, the NMJ, and that's where the nerve and the muscle come into contact, the neuromuscular junction. And we'll talk about all the magical things that take place there to make muscles contract. So there's the word contractility, is when muscles can shorten, lengthen, or remain the same length. It just means that there's tension that's being generated. When muscles elongate, they have the ability to extend. That's the extensibility. All muscles have a degree of extensibility and elasticity, but if they go beyond that, then your soft tissue tears, right? Once soft tissue is stretched beyond their anatomical limit, then the muscles or the tendons either strain or they just tear. Now, when we look at muscle contraction, let's take a look here and see what is happening in letter A in contrast to letter B. So in letter A, the person is starting out, let's say in position 1 with the arm down at the bottom, and the end of the movement is up here in position 2. Remember, gravity is working downward, and here is the resistance. In this case, it's a heavy book, but it could be a dumbbell, it could be a weight, it could be anything. So you have gravity working downwards, you have the resistance or the load, which has weight, that's pulling downward, but the person is able to generate enough tension here in the biceps. So the biceps have an origin up here, and then they have an insertion, we'll put an I, down here on the radius. And when the origin and insertion move closer together, this is a shortening phase. We call this a concentric contraction, and the arm or the forearm moves upward and moves the load or the weight. So when the origin and insertion move closer together, that's a shortening phase, that's a concentric contraction. We also call that the positive contraction or the acceleration. In contrast, B, now the starting position is up here, number 1, and the finishing position is down here at number 2. Gravity is working downwards still, and here they are lowering the load or the resistance of the weight at a slower pace than gravity wants to take it, right? If this was 100 or 200 pound weight plus gravity, the arm would just fall. But here you're in complete control of that movement, slowly lowering it in a way that the origin and insertion are moving further away from each other. There's still tension on the biceps brachii muscle here, but here the O and I, then origin insertion, moved further away. It elongated. That's an eccentric contraction. And the E in eccentric, think of for elongation, right? If you look at the O and I, the origin and insertion of the biceps in an eccentric contraction is longer than the origin insertion in the concentric contraction. The eccentric contraction is known as the negatives. Today, when I went to the gym to work out, I did negatives, right? Where the weight, I slowly lowered it on the way down, and there was tension throughout my biceps the entire way. That's a great way of healthy tension being generated within the muscle, and when there's tension, there could be growth within muscles. The negative contraction is also known as the deceleration. The positive was the acceleration, the negative is the deceleration. So you have a concentric contraction, an eccentric contraction, and in C, what the person is doing here is really just holding out their arm in a steady position. There is no movement taking place. We call it isometric, which means same length, isometer, same length, isometric contraction. There is tension being generated, but there's just no change in any of the joint angles. All these joint angles are staying stationary. So it's isometric. So concentric contraction is when the muscle tension exceeds the resistance and the muscle shortens. That's what happened here. The origin and the insertion approximated each other. They shortened. We call that the positive contraction or the acceleration. Eccentric is when the peak tension is less than the load and the muscle elongates. So the eccentric, the E in eccentric with the E and elongates, and that's when the O and the I, the origin insertion, move further away from one another. That's called the negative contraction or the deceleration. Isometric, same length, the tension never exceeds the resistance, so there's no change in the joint angle whatsoever. So you heard me say O and I for origin and insertion. The origin is usually the more proximal part, and it's usually the part that's staying still, whereas the insertion is the more distal part, and it's usually the part that moves. So if we go back here, the origin was staying still, the insertion was moving. The origin was staying still, and the insertion is what moved. Okay. Agonist. The agonist is the main mover. In this particular case, the main muscle here is the brachialis or the biceps brachii. That's the main mover. That's the agonist. It's the main muscle that provides the movement. The antagonist is saying, hey, what muscle does the opposite? So if we go here, what opposes the biceps? It has to be a muscle on the opposite side, which would be here, the triceps, or here, the triceps. That would be the antagonist. When we look at the synergist, when people work together synergistically, these are just muscles that assist the agonist. So in this case, if the biceps brachii was the main muscle that did elbow flexion, any other elbow flexor is going to be synergistic, like the brachialis, or even the brachioradialis, or any other muscle that crosses the elbow. But the triceps would be antagonistic to it. And the last term is innervation. When the word innervation, we see the word nerve, and it really is the nerve supply to the muscle. Whenever we're talking about muscles of the upper extremity, anything from the shoulder down to the fingers, the nerve that controls that, all of those muscles, come from a plexus called the brachial plexus, which comes from the neck at levels C5 to T1. When we're talking about the lower extremity, from the glutes all the way down to the toes, we have the lumbar plexus or the sacral plexus involved with doing that. Now, off of the brachial plexus, there are a bunch of nerves that you will learn about when you cover neurology in anatomy and physiology too. You will learn that all of the extensors of the elbow are controlled by the radial nerve, and all the flexors and the majority of the flexors of the wrist and fingers are controlled by the median nerve. You will learn that the deltoid and teres minor are controlled by the axillary nerve. But all of those nerves come from the brachial plexus from these levels. Okay? All right, when we come back, we'll talk a little bit more about the microscopic anatomy of skeletal muscle.